A brief synopsis of 1.1. The discriminant refers to what's under the square root in the quadratic formula. So b squared minus 4ac is the discriminant of any quadratic expression or equation of the form ax squared plus bx plus c equals 0. There are three things that can happen with the discriminant. Because this is going to be a number, it's clear that if a, b, and c are the right numbers, this number could be positive. If a, b, and c have certain different values, it could be negative. And if a, b, and c have just the right values, it could be 0. So the discriminant could be positive, negative, or 0, and that's going to give us three different cases. Three different things that can happen with our solutions. First, we illustrate one case with this equation. Okay, x squared plus 3x plus 5 equals 0. The y equals doesn't hurt anything, but right there is the essence of the equation. Ax squared plus bx plus c equals 0. We can see that a being the coefficient of x squared is 1, b being the coefficient of x is 3, c being the number that's left over on this side is 5. Okay. So the discriminant, we just plug 1, 3, and 5 into b squared minus 4ac in the appropriate places, and we get negative 11. Okay, well, how does that work in the quadratic formula? That means we're going to have a negative 11 under the square root, doesn't it? Well, let's go ahead and write out everything that we get. It's not necessary to actually write this solution out, but this is the solution to the equation. The point is that the square root of negative 11, the square root of the discriminant, is an imaginary number. It's the square root of 11 times I. Now, the numbers we get over here are real numbers. So we could do the negative 3 over 2 plus or minus the square root of negative 11 over 2. That's the square root of 11I over 2. There's our solution. The solution has a real part, and then it has plus or minus an imaginary part. That gives us two complex valued solutions, one for the plus, one for the minus. And these are also called complex conjugate solutions. So by this example, we see how it is that a negative discriminant gives us complex conjugate solutions. Again, if this number is negative, then its square root is an imaginary number, and we're going to have a real number plus or minus an imaginary number over a real number, which gives us a real number plus or minus an imaginary number. And it's the same imaginary number that we plus and minus, which makes the solutions complex conjugate. Okay, in this case, we identify A as negative 2, that's the coefficient of x, B as negative 6, C as 3. Plug that into the discriminant. It's very straightforward. We get 60. And if I did my arithmetic right, check me on that. Okay? So what happens? We put that into the quadratic formula. We're going to have a 60 in that square root. Now, you can't tell me exactly in decimal form what the number 60 is. Nobody can, because it's a non-repeating, non-terminating decimal. It's infinitely long. You never get to the end of it. But we can still write it as square root of 60. And that goes into the quadratic formula here. The b, which is negative 6, goes here with a negative in front of it. The a is negative 2, and it goes down here 2 times a. Okay, we don't need all that, but this over this gives us 3 halves, and this over this gives us square root of, square root of 60. Now it actually gives us square root of 60 over negative 4, but since we're doing plus this and minus this, we can just eliminate that negative. We're still going to get the same two numbers when we do the plus and minus as we would if we had the negative 4 down here. And the square root of 60 simplifies to 2 square root of 15. So we end up with 3 halves plus or minus 2 square root of 15 over 4. And of course 2 over 4 is 1 half, so we end up with 3 halves plus or minus square root of 15 over 2. Now that's the whole solution, but what we're really looking at with the discriminant, what the discriminant is going to tell us is how many solutions we have. Well, if the discriminant is positive, we're always going to have a positive number under this square root, which means we're always going to have a positive number here. So this is always going to be some real number. If we plus it, we get one result. If we minus it, we get another result, because this number isn't zero, it's some real number other than zero. Adding, subtracting gives us two different results. So both of these solutions, of course, are real numbers. So when your discriminant is positive, you're always going to get two solutions, and they're going to be real numbers. So I summarize: positive discriminant implies two real solutions, one for the plus, one for the minus. In this case, we plug in R, A, B, and C to the discriminant, and I said the discriminant is the square root of, discriminant is the B squared minus AC without the square root. Okay, it's just B squared minus AC. Now we are going to be taking the square root of it, but okay, if we do the discriminant, we get 6 squared minus 4 times 1 times 9. Work that out, it gives you 0. So the discriminant is 0. So we have x equals -6 plus or minus the square root of 0 over 2 times 1. -6 over 2 is -3, and 0 over whatever is 0. So we have -3 plus or minus 0. Well, -3 plus 0 is the same thing as -3 minus 0. Either way, you get -3. -3 is your only solution, but note that it occurs twice. Once for the plus, once for the minus. And you got to count both of those solutions. So we have what we call a repeated real solution. The number you get here is going to be a real number. The only way you can get an imaginary number is for the discriminant to be negative, and it isn't. Okay, so we see, again from this example, discriminant 0 always yields a repeated real solution.